Hey, welcome everyone, and thanks for joining us. I'm Kendi Farbo. I'm a marketing specialist here at Snaptron, and today I'll be your moderator. I'll be bringing your questions directly to our engineering team today. So we're going to skip the presentation format and get straight into more of a discussion type of webinar today. So think of it as a seat at the table for the kinds of conversations our engineers are having every day with customers and design teams. We're going to cover real questions that come up during design, production, and validation, including several that you submitted while you registered. And if something sparks a question along the way, feel free to put it in the webinar chat, and we'll be keeping an eye on them throughout the discussion, and we'll try to get to as many of them as possible. So before we get started, let's give you a quick introduction to Snaptron. So we design and manufacture metal dome switches used in electronic interfaces across a wide range of industries, from automotive to aerospace to different consumer devices. But we just don't supply the components. Our engineers work directly with customers on design decisions and performance challenges throughout the product process of the development. So the insights you hear today will come from real applications and real engineering conversations that we're actually having every day. So let's get to introducing our team. So first, right next to me, we have Kyle. He's our applications project manager. And then we have Walter Goodrich. He is our VP of engineering, as well as our co-general manager. And last but certainly not least, we have Kevin Albertson, our director of engineering. So I'm here next to a lot of smart guys, a lot of engineering expertise. So let's go ahead and jump right in to these first questions and topics that we have. I'm going to guide us through some of the most common questions that we hear. So feel free to build on each other's answers, disagree, agree, or add more context.
We will.
All right. So let's start at the beginning, dome selection. So when a customer asks, how do I choose the right dome force for my application? Where do you typically begin the conversation, Kyle?
Usually I start asking, what is the industry or sector that this product is going into? And that kind of helps at least narrow it down into a few different options. Say if it's a mobile device with fairly small and intricate buttons, or a control, or some kind of medical device with a membrane switch, or heavy industrial control.
So like, what's the use case?
Exactly. So we go start with the use case, and then that kind of narrows us down to a few different options, and then I'll continue to narrow it down by asking, what do you want the user experience to feel like? Do you want it to be kind of quick, responsive, that will be kind of on the lighter end of the spectrum, or do you want a really heavy, tactile, I made absolute sure that I pressed this switch and I know I have confirmation that that input was received.
Yeah.
Then that'll skew us to the heavier side of the spectrum.
Is it helpful when customers are able to give you a product reference of what they're looking for in their own application?
Yeah, absolutely. That's a great starting point. Say if they have something in their household that they use as a reference, they're like, I want it to be like this force, or I really like the tactile, the clickiness of this piece of electronics that I have in the house. That's a good starting point, and then we usually have an idea of roughly where that lands.
Yeah. Are there certain industries that you guys see that tend to favor a lighter or heavier dome force?
Definitely. Yeah. I mean, like Kyle said, industrial controls are usually pretty heavy. The Department of Defense or military stuff is usually heavier because you got gloved hands. Medical, you got it all the way down from doctor fatigue issues, so they might want it really light versus a medical bed or something like that that can be like a consumer item.
Mm-hmm. Where would you usually start, Kevin?
Yeah, it's going to depend on, again, whether somebody's in a vibration environment. So like in a moving vehicle, like an automobile or an airplane, that's going to push you in a slightly heavier direction. Or if perhaps it's got some sort of a mechanism that's going to push the dome for you rather than the operator pushing the dome directly. So for example, one of these on the steering wheel is pushed by a lever. So it's it might be a completely different dome than what if you were going to push on it directly than if you're pushing and the dome is back in here somewhere.
We've got a lot of projects where you use mechanical advantage, like on the leverage implementation like that, where the force to activate the dome becomes much, much, much higher than if you were to press on it directly.
Or like a foot pedal.
Yeah.
Like that can be a really, really high force application.
Absolutely.
So with that in mind, customers might come to us thinking about a certain dome that they know that they want. But can you think of an example where customers' initial dome selection wasn't the best fit?
For sure. Yeah, they have an idea of maybe a similar product that they've kind of reverse engineered, and that's their starting point that they think. But when they integrate it into their own assembly, they start running into, maybe not the user experience they were hoping for. So they'll either need to dial it up or dial it down to get to what they would like.
A lot of that's affected by what actuator is pushing on the dome, how big the contact point is, what the durometer is of that material, that sort of thing, right?
And that can be quite different than what they were thinking they were looking for
Right.
their experience, right? So once they housed it and packaged it the way they wanted it, it could be completely different.
Right.
What are some common misconceptions that some of our customers will come to us with about dome force initially that we're able to kind of educate them?
What do you think?
I think a lot of misconception comes from perception of the force when you're pressing with your fingers. Say, for example, a larger button feels lighter than a smaller button, even if they're at the same force, because the area that it's applied to is larger. So you kind of have that different perception. For example, this smaller keyboard in front of us has a fairly light 200-gram dome, but it's a fairly small button, and it feels quite stout.
Yeah.
A larger button has a higher force dome in it, but it doesn't feel as heavy when you think of it like that.
Interesting. Why force of dome do you think is in that?
We were thinking right around 300 grams.
300, and yeah, this does give you really that good feedback. To that point, when engineers first start evaluating metal domes for their application, the number of options that we have can be really overwhelming. So can one of you break down briefly some of the different styles, maybe the force range that we offer, and some of the functional features that are available? Who wants to go?
So yeah, we have quite a few different styles, and I think some of the things that really affect that are our different styles have different travels to them, besides different forces, and so that makes it a big difference. Some of our four-legged styles that are much lower, we can have much higher force, which actually gives you the impression that it has quite a bit of tactile. So we can play that role within the assembly as well. So some of our older style domes that are, real old, like the rounds that people have seen forever and ever, are very low travel and very low force, or can be low force. And so that perception of tactile or tactility is quite a bit different than something people really want a high force and a high tactile on.
A lot of times the shape of the dome is going to be dependent on what the rest of the board layout looks like, whether you need to have components up next to it, close to it.
Right.
How much space you have for the dome itself to be what size, right?
Well, that helps us drive kind of the direction of what style of dome as well to use.
Right.
And then on that, we have variations within each overall shape, where we have dimples, upward facing tactile concentrators, ring shaped dimples, backlight holes through the center of them.
Right.
Yeah.
So,
Lots of options.
we have a lot of options.
I'm glad that you mentioned dimples. We actually had a registration question that came in, that someone was interested about dimples. Bob, when he evaluated his design, he wanted to know what factors drive the decision to use a dimple dome versus a non-dimple dome.
Yeah.
That's been a conversation for years, actually.
We get that question a lot. And a lot of the reason why we would opt to use a dome or a non-dimple dome is if there's a solder mask layer in between the center and the outer electrical contacts on the PCB. That solder mask thickness can stand proud of the copper layer that's on the actual contact surface, and that can inhibit the travel of the dome and cause some intermittency issues. So if that's not able to be removed, we definitely recommend opting to a dimple style dome. But the drawback is that it concentrates that entire force into a single point contact, and that can lead to some wear issues later down the road.
Yeah,
And more contamination issues.
right.
So that's one of the reasons we developed a ring dome
Mm.
for the same type of thing, is it gives it a 360-degree contact instead of just a single point of contact. So back in the day, a lot of times we'd look at a dome electrically and functionality, and you would see what we call a tease function to it. So when you push it, you'd feel the click, but you wouldn't register an actual contact. Well, so to get around that, you can put a dimple in it that changes the travel so that you have what you call simultaneous closure.
Mhm.
But when you feel it, you're making contact. So it really depends on dome design too. We've seen a lot of offshore domes that have that functionality, and that's how you get around it. Either that or you buy a dome from us that doesn't have teeth in it.
Right.
Now you're saying the ring dimple is more immune to any sort of contamination?
It is, yeah.
Under the.
Definitely is. That's why we're actually, there's a lot more people going to it.
Yeah.
Actually, compared to just a single dimple, we've seen a lot of micro dimples, which are
Right.
fine too, but the ring is real simple and it works real well.
Anybody curious, you can look at those examples. It's under the RC series on our website.
Right, another great feature that we offer, the features and functionalities, customizations that we offer in our portfolio is pretty endless. So it's always worth taking a look at our website. So kind of talking about the dimple, non-dimple RCG, how much does the end application kind of change the answer of where you start with looking for those different forces?
Now it has everything to do with it. I think we like to take the approach of beginning with the end in mind, right? Have that end application in mind from the very beginning, and instead of trying to shoehorn something that kind of may work and may fit, but doesn't have the optimal results in the end application.
But you might start from a standard dome,
Mhm.
and then if something
Right.
needs to be customized, you need to add a dimple or something like that, then,
Either we have the option already
right.
or we have to create it.
Yep.
So we got a question from David of Proton. He said they're looking for a very light tactile fill and referenced a PC keyboard at roughly 90 grams of force. How would you approach dome selection for this type of application?
We have a lot of low force domes.
Yeah.
I mean, and usually, I mean, for years, the keyboards have been anywhere from 70 to 110 grams. So he's right in the middle of that whole thing. And really, then you just sort of have to look at what he's going to activate that dome with.
Right.
Right. Because you're going to add a little bit or take away or whatever. So if you start with that range, I mean, we have domes all over in that spot.
And then how much travel does,
Right.
is it, like, does he need the travel of a keyboard? Because that's a pretty long travel.
Right.
Right.
Absolutely. That was my next point. And then beyond that, like, what is your space constraint on
Mhm.
the surface of the PCB? Like, how large can that switch footprint take up? And that'll help narrow us down.
Yeah, we'll definitely get there in the conversation. So I'm glad you started talking about that. I guess to kind of wrap up, dome selection for this section, what do you feel like separates a dome that feels good in a sample or a prototype from one that performs well in the actual final application?
You know, we often focus on force or travel or tactile ratio, but
Yeah.
at the end of the day, they all work together to have
Great
an end
experience.
end user experience. Absolutely. So it's helpful to have a target for one or maybe two of those, and then
Yeah.
we'll work with you from there to try to dial it in.
Mhm.
And production tolerances need to be taken into account on the overall assembly, the housing, the
Moldings, all the,
actuator, all of the molding tolerances,
right.
and then the range of force tolerances on hard domes as well. So, you know, you kind of need to be able to take that into account mechanically as well as how the actuation is going to feel.
So we had one more pre-submitted question I wanted to touch on before we move into PCB layout. Someone asked, for applications like gaming where responsiveness is especially important, how do metal domes compare to silicone carbon contact solutions, and what trade-offs should engineers consider?
That's a really good question. It seems like tactile metal domes are going to have a more positive feel and audible and everything else compared to the silicone with carbon pills. They're a little more mushy. I'm not sure anymore. I haven't looked at it for a long time, but I think their cycle rating is a lot less on rubber than it is for our dome. Especially when we used our high life cycle dome, the SQ series, that's rated to 10 million.
And the carbon electrical contact.
And it's higher. It's higher. It's not as
Yeah.
low of a contact as well. That can be electrical guys taking care of that too. But both are. I just think it's a longevity thing and a preference of what the gamer likes from the feel.
Where is the quality different in your opinion?
Well, I mean, if you're looking at life cycle, then yeah.
Yeah.
But I guess that's the only one you can think about. Carbon wear, puck wear, that, yeah. I'd say they don't last longer.
Yeah, life cycle important.
Especially as many cycles they put on as a month.
Right?
The
Yeah.
professional gamers for sure.
I would say, and probably non-professionals as well, but yeah, gaming is really important to have a high life cycle count, as we have a lot of customers or, you know, hobbyists kind of reaching out to us asking us for replacement parts for some of their commercial game controllers. All right, on that note, let's move into PCB and layout design. What are some of the most common PCB or layout mistakes you're seeing in real applications, Walter?
I think the first thing is the PC designer just comes up with his own pattern. We really highly recommend using our recommended patterns. We have them all on Snapchat. Snapmagic, sorry. Snapmagic. I think
we're all Snap here.
Yeah, we're all Snap. You're right. One of the other things is the selection of plating. And a lot of people are getting it right, but a lot of people don't. They need to, I mean, like I say, we offer our design guide and everything else that helps with that as well. So those two things are probably the biggest factor. You have another one?
In addition to that is the bent hole that we recommend under the footprint is extremely crucial, especially when used with a dome and tape layer. That air needs to go somewhere that's underneath the dome, and we provide in our recommended pad layouts the correct size and spacing of that via hole for that venting to occur.
If it's not possible to put a vent hole, how do we mediate that? How do we take care of that?
Well, a lot of times we'll put a vent hole directly into the tape. Now that can add some complexity to our assembly process, but it's a good way to mitigate that in case of not being able to change the PCB. That, and we'll have, in the case of a multi-dome array, a spacer layer with a vent channel that connects multiple domes together, and that provides that venting solution as well.
So between dome cavities, you might have a vent. So you push this dome down and the air moves into this other cavity.
Correct, right.
Oh, okay. Because you're not going to push them all at once.
Maybe. Okay, to that point, so we have a lot of design recommendations when it comes time for recommended ways to place metal domes, venting, and we do have most of these on our website and definitely in our design guide, which is downloadable as well. as well as our footprints and symbols available on Snap Magic.
Snap.
Yes, Snap Magic, but like I love all the snaps, so you kind of can get caught up with it. That was a fun partnership that we did late last year. So we just wanted to touch on the idea that our footprints and symbols are on Snap Magic, which will make them easier to help integrate into your design as well. So I guess, like I said, our design guide covers the fundamentals of recommendations, but what are some of the PCB design insights you've gained through your experience that engineers should also keep in mind?
Well, the other one I have is our keep out areas, how important they are underneath the dome. The solder mass that we were talking about a little earlier. We don't want that material in there. So I think that's one of the important things that we've seen over the time with customers that have come in with problems because they've got it in there.
Right. And on top of that, very long life applications where this device is needing to be reliable over millions and millions of cycles. We have recommendations on thicker plating or hard gold plating that really lends itself to those applications.
And it's always going to be important that the board is mechanically well supported, so
Right.
the flap's not flexing, especially if it's a flex circuit or a thin circuit board. If that flexes, then the dome isn't properly supported by a nice solid surface.
Right, exactly.
So I do want to bring you back to the plating on PCB. We did get a question from Chris. He asked, PCB contact material can have a significant impact on switch performance and longevity. How do you help customers choose between carbon, chemically plated gold, and galvanic gold, and what trade-offs should they consider?
Well, we pretty much, unless very rare circumstances, we don't almost ever recommend carbon plated circuit panels.
But part of that is because we don't have that data for that. I mean, most of the board houses that are doing that, but we have several customers that are doing it,
Right.
that are actually plating carbon and using the dome. And
For just the center contact?
no, for the whole
Really?
contact
Oh,
of the
wow.
feet where the feet sit, everything. So
Okay.
it's just trying to collaborate with those guys to get, they say that they get good life out of it. So, I mean, it's doable.
Right.
Okay.
Definitely doable. It's just that we don't have recommendations because we don't have that data from
Right.
anybody.
Beyond that, we have our, our normal electroless gold plating that's very common, but it is softer. So at a high life cycle application, we'll typically recommend bumping up to an electrolytic placed hard gold deposit on the circuit pad.
But there's certainly nothing wrong with starting with electroless nickel and or
ENIG.
something like ENIG and testing with that and see.
Yeah, because
Kind of results you
the
get.
style of dome, force of dome,
Mhm.
all of that impacts all of that, right? So if you've got a high force dome, well, that means you've got more concentrated
Right.
force at each point.
Right.
Even though the center contact's just a pressure contact, but those feet are,
Yeah.
the outer surface is rubbing, so it's gonna wear.
So, are there applications where it's important to invest in a higher performing contact material?
Absolutely. We deal with them all the time, whether that's from, airplane, aerospace cockpit controls to medical devices, military and broader aerospace applications where it is absolutely worth investing into higher quality materials and assembly.
Low voltage, low current applications, right?
Yeah.
Too.
Absolutely. Battery operated stuff. Even a lot of the automotive applications we see require or want to see those gold plated contacts, for example, and really demand a high threshold.
Has that always been the case for automotive or more recently?
No, I'm gonna say it's been pretty consistent over the years.
Really?
Yeah, especially aerospace too.
Yeah, aerospace. Yeah, definitely. I can see that. So I guess, what we're saying here is PCB pad design really affects the performance of the overall application. We have gotten some interest about single versus double-sided configurations. How should engineers think about those?
It comes down to a cost. Number one, it can be cost, right? Because a single side is going to be less expensive than a double sided. So it really depends on the electronics, what kind of, if it's even capable of having that. I mean, aviation and stuff like that, they've got up to 12 layer boards. So there's a lot of complexity in those kind of applications as well. But if it's cost, try to get single. It's just less expensive.
Right, and then beyond that, if they have different routing requirements for those traces, they might have to do double or single sided, depending on each switch location by itself. Right?
Yeah, and if they need shielding in that as well, most of the time you're going to need two-sided because a majority of the top surface plane is going to be shield or ground or whatever they want to call it. But
Does space on the board have anything to do with maybe why?
yeah, it depends on the components you're going to have.
Mhm.
I mean, look at this one. Right.
Right.
A lot of stuff.
There's a lot of stuff on there, but there's all just the gold contacts on the front, and LEDs, but backside's got a lot on it. So.
Yeah, I mean, it really does. I can put that kind of in the camera a little more to, we're kind of far here, but so you can see all the components on there. I guess a question we get quite often, which is, we know the answer, but sometimes you don't know if you can mix the different dome styles and types on the same type of board. It's okay to do that.
A lot of people do it. Yeah. I mean, I think one of the arrays that we've done was up to 7 different styles or something like that. So it's doable, definitely doable.
And why would a customer want to do that?
Some of those larger keypads have a lot of different variation in button sizes.
Sure.
And or if they've got a directional button where you get your 4 with the center, that's usually a closer knit of spacing.
And that's gonna be different than their
That could be different than all the other buttons. So yeah, I mean, people will put oblongs in too.
Right.
Like oblong ones that are longer on a big button.
Right.
So, and then some switches will have they're normal, normally open momentary, and we'll have our normally closed or other dual touch functionalities all on the same PCB.
So yeah, you could need different functions, different forces, all on the same application, and that would be why you would want to use different dome styles and types on the same board.
Yep.
Okay, so what becomes difficult or impossible to fix once a layout is locked in?
Venting becomes difficult. If the board is finalized and there isn't via holes for venting, that becomes difficult. Then we have to start looking at venting through the tape layer or venting via spacer layer with vent channels. That makes that a little bit more complicated, but not impossible.
I was looking at some of the questions that we have coming in through the chat. Here's one related to PCB layout. Are there any thermal concerns if there are many switches next to each other?
Not thermally, no.
Okay. We had some that came in during our dome selection that we'll probably try to get back to towards the end.
Okay.
Just notating that. But we want to kind of move into assembly reliability, and that's a hard word, and manufacturing. So let's shift from design decisions to execution. So we've talked about design and layout considerations. Once a design is finalized, what assembly practices most commonly impact dome performance? I think there's more to this one. And which are most critical to ensuring consistent switch performance and long-term reliability? That one's for you, Kevin.
Oh boy, I get the long question.
I can repeat things
no,
over if you need.
Well, again, I'm thinking of the assembly tolerances of the overall split of the housing,
Product.
because you're supporting the PCB from underneath, and then the housing needs to come around and then support the actuator, the top side a lot of times. And so you've got the tolerances there. You might have tolerances that of the pocket that the dome sits in, if it's sitting in a plastic housing, and that needs to not restrict the diameter of the dome, because that will affect the way the dome operates. Again, the board, the PCB needs to be well supported. The actuator needs to be able to move smoothly.
It's gotta be the right size.
It's gotta be the right size. It needs to be well centered, reasonably well centered up on the dome itself. And then the array that we make needs to be reasonably well placed on the board itself, right?
Right.
And we make fixtures for that as well, that we can sell,
Yeah, so consistency of application
right?
is a big part of it. That's why a lot of people like the fixtures, is very repeatable and consistent, so placement's really good. Don't have to worry about operators and eyeballs and all that stuff.
Right.
Yeah, so you mentioned how much goes into assembly. So say you have final assembly together, but something still fills off.
Right.
What is like the first thing you look at that could be happening?
Call Kyle.
Yeah, right. Yeah, I see those a lot with
Tolerances for-
with tolerances and stuff.
Yeah.
I would typically say at the assembly level, I start with actuator to dome alignment.
Right.
Mhm.
And if it's off center, it's going to feel a lot different than if it were centered up on the dome itself. So that'd be the first one, and then beyond that, we'll take a look at the actuator diameter compared to the dome's diameter, because we have an optimal ratio that we try to hit. If it's a rubber membrane keyboard, I'll look at the flex webbing within the rubber membrane to see that it's not adding its own amount of actuation force to the overall switch
So
assembly.
like preload
Mhm.
on the dome, so.
It could be just the rubber functioning doesn't function well,
Right.
or the button movement isn't well.
Wrong with the durometer
Yeah.
of the rubber, or if it's a hard plastic keycap, it could be molding defects in the hard.
Right. Injection points, that sort of thing.
You brought this up, like venting
Mhm.
being an issue. still,
Venting's
you
absolutely-
mentioned before, could it be, it's not the right dome?
Yeah, sometimes, I mean, we'll see someone put in a lighter force dome than, or they thought this lighter force dome would work, and then when they put it in the assembly, it doesn't quite have the correct feedback, so we'll just bump them up the force spectrum, and then that's a really quick and easy fix a lot of times.
That actually happens more than
Mhm.
people think.
Huh.
Yeah,
Because we'll go the first round of prototypes, we'll go first round of production, they'll come back and go, oh, we need a little better
Or-
feel.
A little more up to it.
Yeah.
yeah. So we talked about all the things that you might be looking for within the assembly that might be off. This kind of leads us into our next question that was pre-submitted, and it's about what about things outside of the assembly that could be affecting the application. So the question is from Amit about environmental durability. So for metal domes bonded to rubber keypads, what adhesion limits should engineers be aware of when it comes to temperature, humidity, and other environmental factors?
So bonded to the keypad. So that's something we don't do,
Right, not ourselves.
but I'm not sure what their
Well, you
specifications are.
don't normally have to bond the dome to the rubber keypad, that can just kind of sit.
Right,
But
and
we do
maybe
see that quite a bit in the automotive industry, where they bond the dome itself right to the rubber keypad
Oh, really?
membrane,
Okay.
and that's how they install it. So assuming it is in an automotive
Okay.
application,
Let's say.
they go through rigorous testing with heat, humidity, vibration. So I'm not entirely sure the type of material that they use to bond it, but it'll have to be
Within-
focused within that. It's probably some type of silicone adhesive.
But then it's the rubber keypad that's creating the barrier to the
Mhm.
environmental.
Yeah, but I mean, again, if they're talking about the bonding material itself,
Uh-huh.
we don't know what that is. I mean, our product spec range is pretty wide, just for dome. I mean, but yeah, the bonding agent, we're not even sure what they use on that.
Right. As for a data point or some kind of reference, I mean, our typical pressure sensitive acrylic adhesive has a wide range from, I believe, -40°C up to 100°C.
120.
Yeah, and then has quite a bit of resistance to humidity. And so that's where I would start as a reference point.
Okay, so how early in the design process should engineers start considering environmental factors?
Up front.
If you,
Yeah, because it's all part of the whole product design, right?
Right.
I mean, we're just a little component that's in there that we can still be affected by those, but it's always nice to know up front.
all right, anything to add on that one, Kevin?
No.
Sorry to call you out. All right, let's see here. Where are we at on, let's jump into the next topic. So once we are ready to build, I guess let's touch on the assembly options or ways we place the dome on the board that are available to our customers, and what are the advantages to each approach.
Starts.
Kevin.
Well, again, we have fixtures where we can place our peelable arrays that we build. We can sell the fixture to our customers. Our customers can take the array, put it on there, and place it right on the board. We also versions of that do an entire panelized board, do several up all at once. We can also, again, place domes. Our customers place domes loose, as I said, into, let's say, an assembly, a switch assembly.
A pocket of some
A
sort.
pocket, like say an encoder under a shaft, under a rotary shaft. And then, of course, we also have our new solderable dome, which can be placed using an SMT soldering line.
Yeah, great. I'm glad you mentioned soldering, because that is a question that a lot of our customers have about that certain type of placement method. So we do offer a solderable dome within the past 4 years now, it's been, correct?
That's different from our regular domes. Our standard domes would not be soldered,
Right, and
except in special circumstances, very special circumstances.
right, exactly. So there's so much interest in our solderable domes, understanding the benefits, trade-offs, and ideal application for that approach. Kyle, can you walk us through some of those?
Yeah, I think the immediate benefit is that it is a process that's automated, right? So our S-series domes that are SMT compatible go through SMT placement and reflow process, and that can be completely automated compared to our conventional domes that are typically placed with a pressure-sensitive adhesive tape, and that's how they're fixed down. That's typically a manual process that can add cost and complexity to the assembly line. So first and foremost, the benefit is being automated, and it removes that extra step.
Yeah,
And we ship those in tape and reel,
Right.
like any other component would be shipped to for SMT placement.
right, yeah, so this would be like the beginning stages of them getting to that reel.
Right.
This is our solder dome here. Did you have something to add to that, Walter? I could cut you off.
I don't know if No, I mean, like I said, the advantages are you just take the human part out of it and let the machines do it.
Okay, so is there a certain project type that soldering is best for?
I think it's for everything.
It especially lends itself to high volume manufacturing, for sure.
Yeah. We're not sure exactly about shock and vibration. I mean, normally the dome isn't sitting all by itself. It's usually encapsulated, it's captured, that kind of thing. We haven't seen a lot of that yet from anybody saying, hey, we shocked the snot out of this thing and it doesn't work. But I mean, that could be a factor.
Okay,
And then it doesn't have the polyester
Tape cover.
tape covering, which normally would provide the environmental protection.
I know of a customer in a project that they actually do use the SMT line for the domes and put a piece of tape over the top of it.
Okay.
It's an automotive.
Afterward.
It's an automotive thing.
so yeah, you kind of answered a question that was in there, is you can solder the dome as well as place a piece of
Film.
adhesive. Why would you do that?
I think it's just for extra protection. I mean, maybe they were testing and qualifying it and they had problems,
Mhm.
or for extra dust protection.
Yeah, one, it's gonna keep the dome from ever moving out of position.
Yep.
And two, it's gonna seal it up environmentally.
Yep.
Right.
Just checking to see if we had any questions coming in about the soldering topic here. How critical are stencil thickness and solder paste selection in performance?
Very, I would say. You want a good amount of solder paste to be able to reflow and bond that dome to the board. All of our testing and validation has been done with a 5 mil or 5/1000 of an inch stencil thickness. And we've used our in kind of SAC 305 solder paste for all of that as well.
Anything else to add on to that? Okay. Let's see here. Along the same lines of the soldering topic, is E-NIG plating acceptable for solderable dome applications? And are there any PCB finish recommendations you typically provide to customers?
E-NIG is a great starting point. I think a majority of our rigid PCB customers use that. I would say the only time you might need to maybe switch away from E-NIG is in those really high life cycle applications.
How high are we talking?
Probably more than 200,000-300,000 cycles. Is where we start to maybe start looking at different options. But again, it depends on how much force and how small the dome is, and all those factors play a part in that.
What's the life cycle count for our solderable domes? What is the range? Do you know
The
that?
mechanical cycling
Correct.
is 1 million.
Okay. We also had another specific question. An attendee asked whether it's possible to connect only to the outer solder pads of a solderable dome. Is that a viable approach, and what design considerations should engineers be aware of?
Versus like having the feet connected as well.
I believe that they're asking about the solderable points where the actual paste is versus the 4 other kind of feet landing pads. So yes, you can connect just to those 2 solderable points and then have a connection obviously with the center contact, and that will be fine.
Okay.
But we do want pads for the feet to sit on that are the same material, not having it like on the bare FR4.
Right. Yeah.
Or Kapton sheet or
It should
solder
be
mask.
Correct.
We do want them on a pad.
Yeah, you just don't have to.
Yeah, I don't have to have a trace.
Great, you guys are answering these quickly. Are there applications where you would strongly recommend soldering over other assembly methods? I know we kind of touched on that, but maybe be a little more specific.
I would say when labor cost is a big factor, and especially in very high volume applications where you're in the hundreds of thousands or millions of switch positions over the product cycle, then you could see a quite significant savings in labor for that project.
Okay. We kind of touched on different functions and different characteristics of a lot of our dome portfolio. And Rick from API Alliance submitted a question. They're currently using a high volume of adhesive-based dome arrays and would like to explore an SMT version with support for backlighting.
Okay.
Is that a viable option today, and what are the design considerations or trade-offs involved?
Well, if they're talking about just a single light source, then yes, we could put a hole in a solderable dome. That's really, I mean, if that's enough, because again, a lot of people use a lot more LEDs around buttons. I think it depends on how big that button is too. Does it illuminate well enough from a single source? Right. So if it does, then great. That's a great option to go with an SMT version of that solder dome with a hole in it.
But if it's in the, if the LEDs right now are in the crotches between the feet, the solder legs are gonna get in the way of a couple.
Yeah, they have to redesign that and accommodate. I mean, there's still a couple areas you can put some on the outside too to help, but.
So in regards to adding the BL feature to our S series line, we do have the capability of it. Throughout the beginning of this project, we've started out with our normal forces and sizes.
Mhm.
We're fleshing those out before we start adding those extra features into the S series, but we do have the capability and we plan on implementing some of those here soon.
Yeah, so contact us and we'll start working with you on it.
Yeah.
Yeah.
So I know there's a standard hole size that we offer with the BL domes. Would you be able to customize that BL hole on a solderable dome as well?
Yep.
Yeah, within reason, yes, we can shrink or enlarge that whole size from our standard offerings, but at a certain point, there's not enough dome material if it's too big and it doesn't end up performing very well.
Gotcha. And remind me the range size of solderable domes we offer currently in our portfolio now.
Currently, we offer 6.3, 7, 8.5, 10, 12, and 14 millimeters.
Gotcha. Thanks for the reminder. Okay, so whether a dome is soldered, adhesively attached, incorporated into one of our dome arrays, engineers are ultimately trying to achieve the same outcome, consistent performance throughout the entire application and life of the product. That leads us to our next topic, failure modes and field performance. So when customers report changes in tactile fill after product has been in the field, what are the first things you're investigating?
We've seen a lot of different things. I mean, especially if it's been in the field, domes can move out of position.
Mhm.
That'd be an easy one to be able to see if you were taking it apart, or the dome has been fatigued and it's cracked, and fractured.
Or mechanically damaged.
Yeah.
Right.
Oh, you're right. Yeah,
Right,
we've
yeah.
seen people hitting with hammers.
Or by the actuator itself, sometimes that will damage the dome.
Right.
So, sometimes like we talked about before, can it be environmental things they didn't think about before when they were making the product?
Yeah, I've seen mud or water or ingress of all kinds get underneath the dome and really just, it binds up and it doesn't work.
Yeah, so to be specific, what environmental conditions should engineers be designing around?
Well,
I think it's all about sealing. I
right.
mean, if they think it's going to be in any kind of environmental harsh or anything like that, it's got to be sealed.
Right.
I mean, their unit. I mean, the whole thing.
Right, so we can still touch on which conditions they can be designing for, but like what examples of different industries, like might need different types of sealing?
I think like the most extreme example would be marine applications.
So water.
Right, by salt water especially, where we have our multi-layer dome arrays that completely seal out the outside environment. And then we also try to advise our customers to go above and beyond and then again seal the entire assembly, the housing, in addition to that, to get multiple layers of protection.
Or off-highway.
Yes.
Automotive applications.
Irrigation.
Yeah.
We've had several customers within that environment too. They'll have a box and have it inside.
Even recently, we've seen aerospace, those kinds of applications that require EMI shielding, right?
Oh,
Where we have to have
right.
an aluminum shield layer that helps from any electromagnetic interference.
Oh, interesting, like
That's a whole other environment.
yeah.
Electrical, yeah.
But I mean, we're even talking about things where environments are quite dusty can affect, the fill and execution of the dome. So what would you do for something like dust?
A lot of times, just our normal single layer tape array will be able to prevent 99% of dusty applications. At that point, a lot of the extra steps come from at the assembly level.
Okay. I think you kind of touched on this by, like say they're in a very rigid environment, maybe in the mountains somewhere, I don't know. What are like the common design assembly changes that you kind of make when a product needs to survive in that kind of harsh environment? I know you talked about sealing. Is that the only thing?
Well, I think then it goes to recommendations for the customer, what kind of materials they're using,
Mhm.
right? Because you can see in extreme cold, things get stiff. versus in extreme hot, they're more flexible and things like that. So it's really a material selection at that point. I mean, our stuff reacts the same regardless.
Right.
Right? Our metal dome and our tape are the same. So really it's the external rest of that can be very detrimental to that. So we can help with that.
We, like from our adhesives, we do offer different types of material that can be for high heat,
Right.
correct?
Right.
And
So sterilization type product, we've got to go to a polyamide or Kapton, if you want to call it, with a silicone adhesive that's up to rated up to 500 C.
Right.
So that's extreme, but we can do it and we can offer that.
what are I know I'm gonna throw, but I just remember always coming to you for like, what is the temperature threshold for some of these adhesive materials? Can you remember them off the top of your head?
Well, the acrylic stuff and the polyester is, like Kyle said, -40 down about 100, 120, 110, somewhere around there.
Celsius.
Celsius. Yep.
Right.
And then of course the polyamide, like I just mentioned, is like, I think it's -100
Right. All the way to 500.
up to 500.
Oh,
So,
wow.
yeah.
Um,
So I mean, most applications that we've seen, I think, for that are going to be sterilization stuff.
Yeah.
The
Right.
typical, what are they?
Autoclaving.
Autoclaving.
Yeah.
Thank
So
you.
for medical,
Yeah.
Yeah.
surgical application.
that's interesting. All right, well, let's spend some time talking about testing and validation. Since we've been talking about the real world performance factors and how they can influence an application over time. Let's talk about how engineers can build confidence in their designs through testing and validation. When validating a new switch design, what tests do you consider absolutely essential before releasing a product to production?
I think the number one thing is life cycle. Let's make sure that thing's going to cycle well, live well, all that kind of thing.
In the complete assembly.
Yeah, well, unless they've got the specific requirements for the dome upfront, right? So, okay, this is what we want. Again, that will be another validation.
Right.
The first one is our product, will be the dome. And then you're talking about the dome characteristics. What do they want? Force, the tactile response, feel, that kind of thing. That's a huge validation issue that we've got to go through as well. So after that, then if we can validate all of that, which we do, then then the customer needs to put it in their system and see what it looks like too.
Right.
Okay, what types of testing do you recommend? We obviously recommend, our tactile performance, but what other type of testing options are there for customers or those designing an application?
Oh, we can do the electrical circuit testing as well, where if they have a certain threshold that their chip on the board is looking for to measure open or closed on the switch, they need to make sure that that resistance or voltage drop is there and is consistent between button presses.
And then force displacement testing, so that the force curve and travel matches what you expect on the loose domes as well as in the assembly, and then life cycle testing the assembly as well.
So a lot of engineer teams don't have access to these specialized switch testing equipment.
True.
What testing resources and services are available for our customers who need additional validation support and help?
Well, we're just coming out with a new testing services program. So like something like that, if they have a unit like that, we'll bring it in, do our force displacement testing on it, see what that mechanical action looks like. We can actually, if they provide us a harness or we provide us a pinout, we can actually electrically monitor as well with the same machine. So that way we can do all the pre-testing to know where our starting point is. Then we can put it in a life cycle testing and actually cycle test it and monitor it and do whatever they'd like us to do, actually.
And the machine that we use to do most of that testing would be the Sapphire, correct?
Well, force displacement and electrical monitoring, yes, or testing, but then we have pneumatic testers that would do the cycling.
Right. But just, props to our engineering team and the in-house switch tester that they've made, which we kind of relaunched in recent years, the Sapphire. We just have a lot of customers coming to us and buying units, and just speak to how great of a switch tester it was and validation for them.
What you don't realize just pushing on a switch with your finger or with something like that is you can kind of get a feel for what you're feeling, but you're not able to quantify it. Yeah. And you're not able to quantify certain characteristics that you might not even realize that you're feeling. And so when you put your switch under a force displacement tester that will show you the curve, that will show you the maxes and minimums in travel, and you're able to compare different assemblies or different mock-ups of your different prototypes, you will find that you're much better able to control what it is that you're coming up with, that you're deciding on, because you have a way to actually see the numbers and see what the curve looks like. Even something as simple as an actuator shaft that has machining marks in it, and the machining marks end up taking a little bit of force to get loose and get moving, will show up in the curve, and you don't even realize that you're feeling that with your finger. So
there was you talked about tactile switch testing. Why is it important to evaluate both tactile and electrical performance during validation?
Well, you want to know how it's going to perform for sure. And again, it's amazing how many people don't really know how that looks and what that looks like. From a manufacturing standpoint and a product, it's nice to do all that validation upfront, like Kevin's talking. All your data, engineers have that. That can go from design into manufacturing engineering, for monitoring and controlling quality throughout manufacturing. So, and you have quantified material data there to be able to do that with.
So what are you seeing then? What's missing usually from these validation plans that our customers have?
We a lot of times don't see that end of the testing on in the assembly at the customer's facility.
We find out later though.
Right, those actually they come back and ask, yes.
Yeah, I mean, a lot of times they're either, the setup's not quite correct or whatever, I mean, or represents a human, right? Or, we've seen impact problems with some of the validation testing that they've done. They've got a cylinder that's this big, pushing on a button that's this big, and hitting it with, I don't know,
10 pounds
or something, which a human can squeeze like that, but they're not smacking it, impacting it.
Right.
So we've helped people with that too.
Right, I mean, as well as our design recommendations for designing a PCB with metal domes, we also have those for our switch testing as well. So we are getting close to time here, but I wanted to get to this question. They had something specific about testing. Jason from eSwitch, he had a question about higher force dome applications. How does increasing actuation force affect expected life cycle performance? And what should engineers consider when working with forces in the 3 newtons to 30 newtons range?
Yeah, that's a good one. So all things else being held constant, if all you're doing is increasing the actuation force, you're not changing the size, you're not changing the overall shape or the series, you can expect that your lifecycle performance is going to decrease with an increase in actuation force, just because that much more stress is being put through the material. And then you end up battling the fatigue limits of the steel itself. Now looking at 3 newtons to 30 newtons, then you're applications where you might need to change from, say, an F-style dome to an SQ style dome. That's really meant for...
And more size then.
Right.
The diameter.
Right. Increasing your diameter is going to help. And then beyond that, you can also look at options such as double stacking, triple stacking domes, We don't have a whole lot of data to support that that's going to perform super long compared to a single switch application, but we have had customers have good success with it.
Gotcha. Thanks for that answer, Kyle. Just want to get through some of these questions that we had with the time we have left. So we talked about how we have a lot of design recommendations within our design guide. The customers have to work through a lot of unique requirements, you know, whether it's automotive, space constrained designs, environmental challenges, as we talked about, but those might not always fit into the recommendations we have on our website and design guide. How can customers come to us and leverage Snaptron's engineering team throughout that development process?
Simple. Give us a call.
Just call.
Just call. We're here.
We're happy to answer, get on a call,
That's what we're here
go
for.
through
Yeah.
all the things we just talked about.
Yeah, we have, I don't know, on average, probably 5 to 10 customer calls every week where we discuss design challenges and certain constraints on a regular basis, and that's what we're here for. So we're here to support the design and make sure that the end application is suitable for what the project requires.
And really, I mean, we've got a really big catalog of standard parts as well as lots and lots of optional customization. And so, like, you're really not gonna, unless you've been doing this a long time, you're not gonna just figure this out on your own without coming to us. And we can be a great help for you. So
Yeah, and to that point, we do have a range of sizes and styles, which we offer a great prototype kit that you can
Right.
request on our website as well. But beyond those sample domes, how does our product that goes beyond sample kit when you're trying to work through like a custom dome or something?
Yeah, a lot of times the customer will have a good baseline. They'll kind of dial in roughly the actuation force, the size, the travel that's going to work for them, but they might want to tweak some things, maybe have some extra requirements. At that point, they'll typically call us or contact us, and we'll set up a meeting and go through those extra requirements. And a lot of times we've seen a similar situation like that before, so we have a good baseline to jump off of. And we've seen a lot of oddball applications where, you know, it's non-electrical or it's non-tactile or something like that, where we can provide a solution for them.
And there's sometimes where we actually have something we can actually send them as a sample.
Mhm.
Oh, that's what you want to do. Oh,
Right.
we might have something we can show you. So
Right, so it's always worth jumping on the website and filling out that contact form. There's always a human on the other end that's going to answer you. So I think at the end of the day, for our customers, we just want to be there. So reach out to us. We're more than happy to hear from you. So that we are out of time today. So hopefully this was fun and felt a little different than your average webinar, more of like a fun conversation between some smart friends. For those of you who submitted questions, thank you so much for the questions that we didn't get to. Like we said, reach out to us. We're more than happy to answer any questions you have at any time. Let us know if you like this style of webinar and if we should have another one in the future. But thank you for joining us today and have a good rest of your day. Thanks.